Section 2.3, solving systems of linear equations by the elimination or addition method. I always call elimination method. Remember, if it's infinite solutions, you're going to type in 0, 0 for infinite solutions, D&E if it's no solution. So they gave us the equation 2x plus 3y equal to -1 and -2x minus 2y equal to -2. When they're talking about the elimination method, means you are eliminating one of the variables from the other. So we have our equation 2x plus 3y equal to -1, -2x minus 2y equal to -2. First thing you do, you're going to add straight down. In this situation, because one ordered pair, one variable here, the x's, are opposite inside, negative, positive, and a negative, so they cancel each other out. So then we see I had 3y, got rid of 2 of them. I have a y, short 1, short 2, I'm short 3. The y component is -3. To find the x component, you're going to take your solution and pick one of the 2 equations and substitute back in. So I'm going to go with the first one, 2x plus 3y equal to -1. And I'm going to substitute in a y value of -3. So 2x plus 3 times -3 equaling -1. 2x, positive and a negative makes it -9. Remember, you want to combine like terms, so I'm going to add my 9 over. So you get 2x equals, I'm short $1 but found 9, I have 8. And then divide by 2, so x equals 4. So our x value is a 4. That is our point of intersection. Because there's a value for x and y, we know we have one solution. It's consistent. And it's independent. Consistent because there's 2 equation lines. Independent because one is independent of the other. One solution is because they both intersect each other. We look at our next example. And this one it says 3x plus 2y equal to 4 and x plus y equal to 2. So first thing I notice is that the x's are both positive, the y's are both positive. They don't have opposite sign and they don't match, so we need to get rid of one. So in elimination method, you take your 2 equations. And you decide on which one you want to get rid of. It does not matter which one you want. I'm going to get rid of the y's, so I'm going to multiply the second equation by a -2 because I wanted to cancel out with that +2. So you're multiplying the second equation by -2. So the top equation just slides over. The second equation, you're changing the values by multiplying by -2. So -2 times the x, that is -2x. -2 times the y, it's -2y. -2 times a +4, it's a -4. So once you do that, now combine like terms. So 3x and -2x makes it plain x. +2 and -2 cancel out. +4 and -4 gives you 0. So our x value is a 0. You need to go to the y value. So you pick one of your 2 original equations. I'm going to pick the second one. So x plus y equal to 2. And in place of x, I'm going to put in a 0. So y is equal to 2. Our y value is a 2. Because of our points of intersection, we know we are one solution. We are consistent. And we are independent. Moving on to example 3. When we look at example 3, it says 4x minus 3y equal to -7, 4y minus 2x equal to -4. First thing I notice in this problem, your x's and y's are not lining up. So first thing we're going to do is rearrange. So I'm going to keep 4x minus 3y equal to -7. And I'm swapping the positions of the x's and y's. So it's now -2x, positive 4y equaling -4. I wanted my x's and y's to line up. Now I notice that there is a plus minus situation for the x's and for the y's. But I can change the x's Instead of affecting both equations, I can change just one. And if I multiply the second one by a positive 2, I become -4, which will eliminate my x's. So if we drag the first one over, and now we're multiplying by -2 into the second one, positive 2 into the second one. So positive 2 and a -2, there's my -4x. Positive 2 and positive 4, positive 8y. Positive 2 and -4, -8. Notice that my positive 4x and -4x cancel. I'm short $3, but I found 8. I have $5 with a y. I'm short 7 and short 8 more. I'm short 15. Divide both sides by 5. So y is equal to -3. So the y component is a -3. Now pick one of the two equations of the originals to find the y. You can go to here, or you can just go to right here, the ones that were rearranged. I'm going to go with the first equation, which is 4x minus 3y equaling -7. And I'm going to substitute in the y value into the equation. So 4x minus 3 times -3 equaling -7. 4x, negative and negative makes it positive 9. We're going to subtract 9 over because we had to cross that bridge. So 4x equals, I'm short 7, short 9, I'm short 16. Then divide both sides by 4, so x equals -4. So again, since we had an x and y value, we know we are one solution. We are consistent. And we are independent. Going on to the next example. So if I drag my paper up, we notice that it says x plus y equal to 5, 2x plus 2y equal to 10. So first thing, I write my two equations. Here you get an option to decide which variable you want to get rid of. It does not matter. I'm going to go with the x's. Since I have a positive 2 here, I'm going to multiply the top one by -2 to change the equation. So -2 times x is -2x. -2 times y is -2y. -2 times 5 is -10. Slide over the second equation. I have positive 2, positive 2y, positive 10. When I combine like terms, I'm -2 and positive 2 cancels. -2 and positive 2 cancels, which gave me a 0 on the left. Equal sign, -10 and positive 10 gives you a 0 because it canceled. So when you see 0 equals 0, for example, 0 equals 0, 7 equals 7, 20 equals 20. Anytime you see any of these situations, this is known as infinite solutions, which means it is consistent, but they are dependent because one graph is sitting on top of the other. Now, because it is infinite solutions, for infinite solutions, it says type 0, 0. So you're going to take the little O's, type in OO, OO, lowercase. For both of them to represent infinite solutions. Moving on to the next example. Okay, so in this example, it says y equals 5x plus 5, 5y equals 25x. So first thing, rewrite this so the x's and y's are together. So I'm subtracting 5x to the left, subtracting 25x to the left. So we see -5x plus y equaling positive 5, -25x plus 5y equaling 0. Because the minute I move the -25 over, it left nothing on the other side, on the right side, so it becomes a 0. Okay, so you can eliminate x's or y's, depending on whichever one you want, does not matter. So I'm going to go with the y values. Since I already have a positive 5, if I multiply the top line by -5, I become a cancellation portion. So multiplying by -5 on top. So -5 and -5 makes it positive 25 with an x. -5 and positive y is -5y equals -5 and 5 is -25. Then we go to the bottom equation. All we're going to do is slide it over. So we have -25x, positive 5y, and 0. When you combine straight down, positive 25 and -25 cancels out. -5 and positive 5 cancels out, leaving you with 0. And we get -25 and 0, making it -25, which is not possible. So, for example, if you get 0 equaling -25, 0 equaling positive 7, 0 equaling 100, this is no solution. What does that mean? It means we have two parallel lines, no solution, it's inconsistent, but they're independent because you see two graph lines. So for here, for our options, you're going to type in D and E for both boxes. So D and E, saying that there is no solution for this problem.